So in this video, we're going to balance a redox reaction that is in basic solution, and we're going to follow all these steps, but add in this piece in right here, number 5. Step number 1 is to go through and assign oxidation numbers, and in this one, we're going to assign the easy ones first. This is -2, which means manganese is +4. This one is -2, which means manganese is +7, and we can see manganese goes from 7 to 2, and so that's our reduction half reaction because it's reduced or it goes down in charge. Assigning these might be a little bit more difficult. Obviously, oxygen's -2 almost always, and then when given a choice, look on your periodic table and pick the element that's the most electronegative and then stick with its charge. So we can see that nitrogen is a little bit closer to fluorine. So if anything's a little bit closer to fluorine than another thing, pick that charge that it normally is. And you usually be okay. So in this case, -3 for nitrogen, because it usually normally is. And that means that carbon's got to be +4, which makes sense because it's usually +4, but not always. Over here, it's a little bit more important to pick the thing that's a little more electronegative, and so nitrogen right here would be -3. That means carbon's going to have to be +2 to make this end up being -1 right here. So when you're given tough ones like that, that's usually the rule of thumb to follow. Now we'll write our half reactions, and our first half reaction is the one with cyanide, so Cn-, and that's going to go to CnO- because we see it goes up in charge, and so this is our oxidation half reaction. Our reduction half reaction is going to be the MnO4- going to MnO2. We can see here it goes from 7 to 4, so it goes down in charge, and so it is reduced. Now let's follow the steps for each one of these half reactions. Balance everything other than hydrogen and oxygen. The carbons and the manganeses and the nitrogens are okay. Balance oxygen with water, 1 oxygen here, so that means I'm going to need 1 oxygen here, and I'll balance it with water. 2 oxygens here, 4 here, so that means I'm going to need 2 waters over here to give me 2 oxygens. 2 plus 2 is 4, and there's 4. Next, balance the hydrogens with H+. I have 4 H pluses here, so I will need 4 H pluses here on this side. Here I have 2 hydrogens, and so I'm going to need 2 H pluses on this side. Next, balance the electrons for charge. I have a charge of -1 on this side. On this side, I have a charge of +1, a -1 and +2. So I will need 2 electrons here to make it be -1 on this side overall in the reaction. And then it's -1 over here. This is a total of +4 and -1, or +3. And then over here I have 0. So I'm going to need 3 electrons here to balance this out to make sure that it's 0 on this side and 0 on this side. Multiply the reactions so the electrons are equal. So multiply this one would have to be multiplied by 3. Multiply this one would have to be multiplied by 2, because then I'd get 6 electrons here, and 3 times 2 are 6 electrons here. All right, once I've done that, now I can rewrite the reactions down below and distribute this 3 into each one of these species. Be careful when you copy these. I've made many an error here in copying it, and hopefully I distribute the 3 correctly into each one of these species. Notice how the 3 went here, and it's 3 times 2 or 6. 3 times 2 or 6. And then for this one, distribute the 2, so I end up with 6 electrons. 2 times 4 is 8. 2 times 1 is 2. 2, 4. And then be careful of the pluses and minuses up here too. You want to make sure those are right. So now I have the same number of electrons on both sides, and since the reactions have equal number of electrons, I can add the 2 reactions together and simplify. I'm going to simplify this first so I don't have to rewrite that because I know the electrons are the same. I'm also going to simplify this one. I notice how there's 3 waters right here, and 4 waters right here, so I'll end up with only 1 water right here in my reaction. And then you'll notice I have 6 hydrogens right here, and I have 8 right here, so I'm going to end up with 2 hydrogens right here. Now carefully take everything on this side and recopy it, and everything on this side and recopy it. So let's be really careful with this and write Cn minus 3 of them, plus 2 H pluses, plus 2 MnO4 minuses, arrow. And then this is 3 CnOs, none, none, and then 2 MnO2s, and then 1 water, so an HOH right here. Alright, it looks like I copied it correctly, and now before I check it, I'm going to have to make sure it's in basic solution. Right now we're assuming it's in acidic solution because it's got an H pluses right here, but technically since it's in basic solution there's lots of OH minuses, and so I'm going to add 2 OH minuses to both sides of this reaction. It's like math class, you can add something to both sides as long as it's the same. And when this happens, I now get rid of these H pluses, and this becomes 2 water molecules, 2 HOHs, and these 2 OHs sit over here indicating that we're in a basic solution. This also allows me to cancel 1 more water, so this water goes away and I only have 1 water left here on this side. Now let's carefully rewrite this. 3Cn minus plus 1 water plus 2 MnO4 minus, arrow 3CnO minus, plus 2 MnO2, no charge, plus 2 OH minus. Now let's check and see if I copied everything correctly. Oh boy, dangerous time. So I have 3 carbons and 3 carbons, 3 nitrogens, 3 nitrogens, 2 manganeses, 2 manganeses. Those are the easy ones. 2 hydrogens, 2 hydrogens, and now the oxygens. 8 plus 1 is 9 oxygens. 3 plus 4 is 7, 8, 9 oxygens. Wow, it's balanced for mass. Now let's check it for charge. On this side, I have 3 negative plus 2 negative, or negative 5 total. And on this side, I have 3 negative and 2 negative, or negative 5. It's balanced for charge as well. Good luck with balancing your redox reactions.